Hi everyone. In this given problem statement, we have to solve combination. Given two integers n and k, we have to return all the combination of k numbers chosen from the range 1 to n. So basically, given a range of let's say n equal to 4, so we have to create a list which is going to contain 1, 2, 3, 4, and you have to return all the combination of size of let's say 1, 2, then 1, 3. So how can we do it? So one way of doing it is using a backtracking function. So here, right, the most important thing to understand, right, let me do a recursive tree. Initially, you are going to pass in an empty sublist. There, we are going to add 1. We can add 2. We can add 3. And we can add 4. Then from 1, right, we can add 2 because here we are having all the values 1, 2, 3, 4. So 1 got added, right? Now our list is containing only 2, 3, 4. Okay. So we can add 1, 2, 1, 3, and 1, 4. So now our base condition is, right, if our sublist, if length of sub list is equal to the kth value, then I can say res dot append the sublist. And here you need to remember, right, we are passing by reference. So to create a copy, I can pass it in this way and I can return. So this would be a base condition. Now once those are been done, right, so ideally, right, how it is working. So I pass in 1 and 2. So after 1 and 2 is getting added, right, I add it to result and then I pop out 2 to add 3, then pop out 3 to add 4, pop out 4, and then pop out 1, means it is a backtracking that we are using. So pop out 1 and we are going to get 2. So now from 2, right, the values that I can add out here is just 3 and 4. So I can add 2, 3, remove 3, and I can add 2 and 4. Similarly, I can pop out 4, pop out 2. I can add 3, and in 3, right, only combination that I can add, right, is 4, because here we have only 4 left. This is not required. So if I create the backtracking function, so it would be like I have this one, and here I can say for index, means for I in range, it would be index to our n plus 1, because it's an inclusive range. So, and this would be a function, we can say if backtrack, and it is going to have the index and the sublist. So here I can say I can add the value to sub dot append. So initially, right, it would be empty, but now let's say it would get added by the current I. And once that is done, I can call the backtrack function. and it would be, I have already added, let's say 1, then my pointer or index would be pointing to 2. So it would be I plus 1 and the sublist. So 1 got added. Now this is not equal to this value, so it is going to come here. Again 2 is going to get added, and again we are going to do a backtrack. So once the backtrack has been called, right, so I'm going to add the result. Then I am going to come back out here, and there it is already 2, right? I have to remove it. So I can say sub dot pop, and it is going to work in this way. So this would be the basic idea how to write this combination. Now let me jump to the Python solution, where if I write the code, I think things are going to get even more clearer to you. The first thing that we need to do, right, we have to create a result where we are going to store our results values. Now I can create my backtracking function. So backtracking, and it is going to have the value of index and the sub list which we are forming. Now I have to write the base condition. So if length of sublist is equal to k, so in that case I can say result dot append the sublist, and I can return it up. Else I can say for I in range, and it would be going from index to n. And here, for the first thing I am going to do, right, I'm going to add this value to sub list dot append my current ith value, and then I'm going to call the backtrack function. Backtracking, and here it would be I plus 1 and the current sublist. And at last, once let's say 1 got added and 2 got added, right, the value is full. So in that case I can pop out the elements. So I can say sublist dot pop, so the next element can be added. So in this way it is going to work. I am going to initialize my backtracking function with backtracking, and I am going to initialize with 1 and an empty list, and at last I can return the result. Let me run the code. I hope it should work. Yeah, maybe it is going to take 0. Yeah, I made one mistake, and which is like, it is an inclusive, right? It should be n plus 1 instead of n. Let me run the code. As you could see, the public test case is passed. Let me submit it up. And all the test cases ran successfully. So let me submit it. It's going to give even better result. Like I've seen it going till 90 or something. So it's pretty efficient in that regard. There is also a function in Python called I think from collection import combination. So if you use that function, you can also get the total number of combination, but here it's better to understand, right, how using recursion and backtracking we can create it. That's all for this video. See you in the next one.